What is an executor?
It is a JVM process that runs on
Okay,
worker nodes.
very good. What is a task? Purna?
A piece of work run in the distributed partitions.
Okay. Stages. What is the stages?
Dividing transformation based on set of tasks.
Stages are like nothing but collection of tasks. So the stages will be created based on the type of transformations. Okay. Okay. So some test we have, I told, have uploaded, right? So how many of you feel that it's easy, or I mean, how many of you gone through the test?
Not yet, we are doing it on weekend. This week.
Okay. Okay. Please go through it. Okay, let me share my screen. So it's actually useful. You guys can expect such kind of tests during your interview. And what is the key by operation, Rishabh?
It is used to convert a single element to paired RDD.
Okay.
So the first element will become the key, the second element will be the original element in the RDD.
Okay. 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 So I have asked you guys to try the Cartesian. So how many of you guys tried? Cartesian. Okay, let's look at today Cartesian. What is the Cartesian product?
It will be the product of each element from A to each element in B.
Yes, it will be product of each element from one set to each element in another set. Okay, normally we can call it as a set. So, okay, let me write a simple example here. While RDD set 1, I can set A equal to sc dot parallelize list of. Let me take a very simple test. Okay, 1 comma 2 comma 3 comma 4. Similarly, this is B 5 6 7 8. I have a two sets. Now when I say dot Cartesian P, okay, say dot collect. Cartesian also a transformation. You have to write a collect to print on the console. If you want to print like this, you can also use for each. Okay. Let it start. Just show an example. You can see how it has been paired. You can see how it has been paired. Is collect is an action or a transformation? Is collect is a action
Action.
or a
Action.
action? Okay. And count. What about count?
It's also action.
It's also an action. There is something called take.
Action.
Okay. There is something called head tail also, right? First, we have seen this one, right? These are not member of this. Okay. So what else transformations we have? Okay. I'll ask one question. Give me an answer. Um, it's coming pair RTD, right? I don't want the pair RTD. Let me create one random RTD. Okay. Now I'm going to write dot take order. So what will be the output of this? What will be the output of this?
Is it 1 comma 2 comma 2?
It's a 1 comma 2 comma 2. Very good. What is the take order it will do? It will first sort the elements, then it will take the, based on what number you pass, it will take that. Okay. Okay, let me, okay. Okay, anything you come across? Any other, what else we have? Let me take this one. Let's do these things. Yeah, let me, anyway, we are looking at the actions. What is the save as text file? Like that, what are the supported one? Let me show you that. Save as text file, save as object file. What is the save as text file? There is something called save as sequence file also. But it's not showing this time. Why? If you have a key value pair, then you have a sequence file. Save as sequence file. Okay. Let me explain what is a sequence file. How many of you are aware of sequence file? What is a sequence file? Okay. Let me take pen pad. Sequence file is a binary file, guys. Okay, it's a key value pair. It's a key value file format. Okay, the keys. Okay, let me explain this. It's a key value pair format. The file will be like this. The file will be like this. Key value. Key to value 2. Key 3. Value 3. Value n. So internally the file will store like this. Okay. So for example, let's take an example. We have a small files in HDFS. Okay. Before that, what is a small file problem? We discussed about the small file problem. This is also one of the most popular interview. What is a small file problem?
If we have many small files, then the metadata will be huge. It will be a burden on metadata actually.
Okay. If I have so many small files, it will be burden on the metadata file in name node. Simple example. I won't take much time because it's already I have explained. I have 1 MB file. File name is a.txt. When I load into HDFS, one block will be created. When I create this, file mapping and block mapping will take 150 bytes of memory in name node. Like this, if I have 100 files, if I have 100 files, 100th files also will take one block only. Its size also occupies 150 bytes in the name node. Now, what is the total size here? 100 MB. Total size, whatever it is, 100 MB because 100 files. So 1, 2, 3, and so on, 100. So 100 MB, how much memory it is occupied? 150 bytes into 100, which is 15,000 bytes of memory occupied in name node. Instead of 100 small files, if I load 100 MB file, how many blocks will be created? How many blocks will be created? How many blocks, guys?
One block, Ravi.
It will create one block. When it is a one block, how much amount of memory it will be occupied in the name node? 150 bytes. So the same 100 MB with 100 small files, it is taking 15,000 bytes of memory, which is the same file with the same size of the file, only one file, it is a 150 bytes. Which is better? One second. Hello? 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 Okay. Which one is better? Storing 100 small files or one big file? One big file, right? That's where
One big file.
Hadoop says that store small number of large files instead of large number of small files, right? This is called small file problem. When you have this kind of problem, what we can do, all these small files we can read into Java, we can convert into one big file. Something like we'll merge it, we'll create one big file. So other way of it, collect all the small file, create one sequence file, .seq, create one sequence file. Okay, how we will create a sequence file? All these keys you can load it as a file name. All these values you load it as a content of the file. Okay, the sequence file actually stores in the different format, like block wise internally. Okay, block wise it will store. So when it has to divide into split, try to remember, guys. When it has to divide into split, suppose it is dividing into splits, two splits. It will not divide here, guys. It will not divide like this. It never do that. Whenever it has to divide, it will always make sure that all key value pair comes into one partition or one block, one input split. It will divide like this. It will not divide. Key will be one partition, val will be in different partition. No, it will not divide. That's an advantage we get with a sequence file. Okay, so in sequence file, your input splits will grow, will be bigger than actual size, little bigger than actual size. Okay, that's the one advantage. Any questions about the sequence file? The sequence file is a key value pair where the key and value will be stored. I mean, the data, the actual data will store in the value. The key will be, sometimes the key can be null. Try to remember. Key can be null. No need to be always have a value. Key can be null. Value will be bytes. Okay. Okay. Next. I mean, why it come like I was discussing about the file format actions, and there is one more action. Count by key. When you do count by key, it gives you these are the keys. 1 4 times came, 2 4 times came, 3 4 times came, 4 4 times came. Can anyone tell why? It's a Cartesian product, no? It's the Cartesian, right? So here, how many times the 1 is there? Okay, so that's the reason. Are you guys making a note? In interview, people may not ask all these transformations, but randomly they may ask. Randomly they may ask, give some examples for the actions, give some examples for the transformation. So that time, it's a more important. Okay, now I'm going to discuss about another most important topic for interview and for your real time. See something like persist and unpersist and cache. Okay, the most important for interview. Please make a note it. Okay, I'll create a different. After take order, these are all fine. Cartesian, save as file, save as text files. I mean, save as text file, save as sequence file, save as object file. These are all different. Okay, let's take a different. Can anyone help me with the common steps? No, I can copy from here. This time, let me use console. Then I'll copy the content into the this time. I want to read a bigger file. I want to read a bigger file. What it contains the bigger file. Okay, let me explain before it actually displays in the console. There are two things. One is cache and persist. Okay, what is the purpose of these transformations? Let me explain. I have RDD. By loading the data, It can be parallelized or it can be text file, whatever it is. On this, I have applied map transformation. I got RDD1. Then I applied filter transformation. I got RDD2. I applied some flat map transformation. I got RDD3. And I applied some distinct. I got RDD4. I got some Cartesian RDD5. Now, this is on top of RDD5, I thought to apply an action. The first action what I have applied is collect. What will happen when you call an action? Any guesses? It will call a compute method in this, and it check does it has any parents, any dependency chain is there. Yes, it is dependent on the RDD4. Then it will go and talk to RDD4's dependency. Then it will also check is there any dependency. Yes, dependency is there RDD3. Then RDD3, then dependency is there RDD2. Then again dependency is there RDD1. Then again dependency is there RDD. So RDD does not have any dependency. It's a base RDD. The first RDD whatever you create with it by loading the data or by loading the text or text file or parallelized method, that will call as a base RDD. Base RDD will not have any parents, right? Since that's the first RDD. Then when it finds the base RDD, then it will start load the data. That's called lazy evaluation we discussed, right? Then it loads the data, applies the transformation, returns the RDD1. Then it loads the data and returns RDD2. Loads the data RDD3. And it loads the data RDD4 and it loads the data RDD5. Then finally it returns the data. This is what happens. This is what happens. Now I called another action on this. This is save as text file. Now you guys tell me, do I need to do the recalculation from RDD5, RDD4, RDD3? Do I need to do the recalculation or not?
Yes.
Recomputation. Simply saying recomputation. Do I need to do the recomputation or not?
Yes. Yes.
So to avoid that recomputation, duplicate computation, okay, we will call persist or cache. Persist or cache. What they do? Persist cache. What they do? They will save the RDD into memory. If you use cache, if your RDD's data fit enough into the memory, it can fit into the memory. Let's say I have a 100 GB of the memory, RDD5 own hardly 5 GB. Happily it will fit. So I can call cache. I have a 10 GB of memory. I have 8 GB of my RDD. Happily it will fit. Persist. Then why persist? Persist actually comes with 6 different storage levels. Different storage levels. If your data is not fit enough into the memory, let's say my RAM is 10 GB, my data is 15 GB, it will not fit. That time cache will not work. So we will go with the persist. What persist will do? Persist will load the data. It has, as I said, it has a 6 storage levels, right? Memory only. Okay, let me show you this with the document. I think you guys can read sometime. here or there, and you can see. It comes under here only. Persist. Look at here. If anyone wants to read, I can just go ahead and read it for benefit of you guys. When you're going reading through this any blog or any document, you will recollect what I have explained. One of the most important capabilities in Spark is persisting or cache a data set in the memory across the operations. Okay, when you persist an RDD, each node stores any partition of it that it computes in the memory and reuses them in other action on that data set. Other action on that data set. This is what I have explained you. When you call multiple actions, to avoid the recomputation. So it's already computed and it stored the information. Whenever any other other action is performed, it will return that. It will avoid the recomputation. This allows future actions to be much faster. Cache is a key tool for iterative algorithms and fast interactive use. It is the latest 3.0. The definition for other earlier version also is a similar. Okay, it's not changed. You can mark RDD to be persisted using persist or cache in case the method can fit into memory, go with the cache. Even you can, if the memory can fit into the, if data can fit into the memory, you can go with the persist with the memory only. Persist with the memory only. You can go with it. By default is that is the only. The first time it computed in action, it will kept that in memory on that nodes, because we will be having multiple worker nodes, right? Every node will have their own cache information, right? So the respective partitions will be loaded into respective cache memory. Spark cache is a fault tolerant. If any partition of RDD is lost, it will automatically recompute it using the transformations that originally created it. What is the meaning of it? What is the meaning of it? The meaning of it is not only computing and storing, it will also stores that DAG information. It also stores the DAG information. That is the reason in case of any failure happen, still you can collect, compute, recompute, to say, it can, most important guys, try to remember it. In addition, each persisted RDD can be stored using a different storage level. If the data is not fit enough into the memory, I'm looking for other option, memory and disk. Store RDDs as a deserialized Java objects in JVM. If the RDD does not fit in memory, store the partitions that did not fit on what is this? Not fit on memory, right? And read them from where they are needed. Not fit in memory, store the partitions that did not fit on disk, not disk, it should be on memory, and read them from the wherever it's required. Memory only with the serialization. Memory and disk serialization. SCR means disk only. Memory only underscore two partitions. Memory and disk two means two partitions. And a half heap still is an experimental phase, so it's not yet implemented. Okay, these are the different levels. When I say 6 levels, first these three and these three, I ignored that experimental one. So 6 storage levels are there in case of persist. In case of persist. Any questions so far? This is a very frequently asking question, and people may ask what are the different storage levels for the persist. Okay, if you want to see in detail, we can call here. Persist default storage level is memory only, default memory only, default memory only. Caches, you really no need to pass anything. If you see the cache is actually persist with the memory only. Persist this RDD with the default storage level memory. That's nothing but cache. That is nothing but cache. Okay. It look at here the persist with the storage levels. Persist with the storage levels. Okay. Persist with the storage level. And persist cache, and there is something called checkpoint. There is something called checkpoint. What is the checkpoint, sir? Let me check whether I do have a checkpoint here. I have. I'll explain in detail. I don't want to make you confused now. Okay, I'll explain checkpoint later, but you can look at here. An option holding our checkpoint RDD if we are checkpointed. Okay, checkpoint data also there is something. So it will actually checkpoints the data. Will tell you what is the checkpoint and how it will store. Okay. If you want to see list of methods used in that program, you can use control F12. 1 second. Cursor, you have to keep the cursor in that file. Control F12. It will list out all the functions in that file. Get partition, partitioner, all these things. They're all methods. Cache, persist. Okay, this is what we are discussing. Any questions? Any questions about the persist and cache? The most frequently asking interview question. Most frequently asking interview question. Okay. Oh, it's actually failed because of memory, because it's the whole memory is not able to fit into the whatever the data I have in the RDD. I tried to collect. So when I try to do the collect, what will happen? It will try to fit into the memory. So if my RAM is not enough to store, this is one of the best example for your out of memory exception. I have loaded the bigger file, right? I have loaded the bigger file and I call the collect. I used to tell, so don't call collect or count unnecessarily. When you call it, what will happen? It will try to fit, it will try to bring all the data and store into the memory because the computation has to go through in the memory. Then what will happen? When the data is not fit into memory, it will just go ahead and fail. Okay, so this is the out of memory exception. Any guesses how to resolve this out of memory exception? How to resolve this out of memory exception? Any guesses? Okay, think about it, and if you guys can answer by tomorrow, that's well and good. Okay, let it load. I want to show you this persistent cache in the UI. By the time I'll go to word count program, go to this word count program, because I have multiple transformations here. I have a reading a text file, I have a flat map, okay, then I have a map, then I have a reduce by key. So let's see. It is loading very slow. Okay, I'll just go ahead and execute these transformations. It's not a bigger file, it's a small file only. I'll show that bigger file to actually transform bigger files loading the data also. Let me do one thing. Let me do the flat map transformation. Let me do map transformation. Let me do reduce by key transformation. Let me do, I'll just do collect here. Okay, pause. Now if you go and see in UI, I have called collect. In the collect you have a stages, stage 0, stage 1, because yeah, this is the first, I just started my console. So first program it is only, so it is, that's the reason start with the stage 0, right? And when you go with the storage, then nothing is there, right? Storage, nothing is there. Okay, stages, these are the two stages, map and collect. We have seen two stages, and different stages, right? This is stage 1, another one is stage 2, and also um, we don't have storage. Firstly, let me look into this. We don't have any storage. Let's go here. Before I call collect, I'll do cache. I'll do cache. If you do directly cache, and if you go ahead and look into these stages, it will not reflected anything. Why? Because you have not called action yet. Call action. You see here. See here. Cache two partitions. Okay, let's see here what is the number of total number of partitions. Two partitions only. Okay. Total number of partitions 2. Fraction cached. I'll tell you what is a fraction cached. Fraction cached means I'll explain this while explaining the Spark memory in detail, but I'll tell you now as an intro. Spark, when you allocate some memory for Spark, it is not only one category. It is actually 4 categories: user memory, reserved memory, execution memory, storage memory. There are 4 parts. Reserved and user memory is not going, we are not going to use very frequently. That is used for the user details and libraries, that information. Your storage and process, this is the most important. What are the transformations you are using? That's all execution memory, the process memory or execution memory. Whenever you call cache or persist, that is storage memory. So there will be something called fraction between them. It is a dynamic. Earlier it was a static. Let's say if I have a 10 GB, 5 GB for storage, 5 GB for execution. storage memory, execution memory. So that time it was a 50-50. So even though the storage memory was free, the execution memory was not able to make use of it because it's a fixed and it was static. Now it's a dynamic. Okay, that is the reason your storage memory 5 GB, execution memory 5 GB, but when execution memory required 1 more GB, it can go and borrow from the storage memory. Whatever the data was there in the storage memory, it will spill into the disk. It is there in the recent versions. I mean, dynamic allocation of the memory. So this fractions refers that whether the whole memory, everything is stored in 100% memory, or it is occupied, is it borrowed something from the other disk and other stuff. Are you guys execution memory is borrowing from the execution or not? Is this clear? And also this fraction cache will help you to understand is this the whole data stored in the memory inside the memory or a disk also. Okay, so here 100% everything is stored in memory only. That's the reason your disk is 0 bytes. And also you can see that how many replicated 0, I mean 1. There is no replication. Are you guys clear about this window, I mean this page? Okay, how will I know what is the storage level for this? How will I know what is the storage level for this? Okay, you did the persist, and how will I know what is the I did cache, right? Now there is something called get storage level. There is something called get storage level. What is the storage level here? Memory deserialized, only one replica. Only one replica. Okay, now let's assume that my data is not fit enough into the cache memory, so I cannot use the cache. I will go for the persist. Persist. Look at here, guys. I'm just calling persist. Okay, but still, look at one thing now. Uh, it's still in the memory, right? The cache I have already done. I'm going to do again a persist. After doing the persist again, I need to call an action. I have called an action. Go to the console and look at this. Okay, it is stored. I want to remove the data from the memory. Still, it is in the memory only, the data. I want to remove the data from the memory. Can anyone tell how can I remove that? Can anyone tell how can I remove that? It's a frequently asking interview question. It's also unpersist. There is something called unpersist. There is something called unpersist. I did unpersist. Okay, I did unpersist. Directly go ahead and refresh the page. Removed. No data. Removed. No data. Now again go ahead here, do the persist. Okay, we need to do the storage level. So to do the storage level, we need to import the storage level. Let me show that. Why to import storage level dot whatever we have seen here now in the web page. Memory only, memory and disk. Let me use memory and disk. Memory only I have already shown, right? Let me use memory and disk. It will saying that no, I cannot recognize storage level. So for that we need to import. Okay, so import org.apache dot spark dot storage. You can use the tab storage dot storage level. storage level. Okay, now you execute this whatever you have executed earlier. Yes. So I did the persist with the memory and the disk. Let's go ahead and refresh here. Still it's not come. Why? Still it is not come. Why? I have not called action yet. Let's call an action. Now go ahead and refresh. Now go ahead and refresh. So still its memories are, yeah, because the data can fit into the memory. Okay. If it is beyond, it's not able to fit into the memory, then it will share with the disk. Okay. Let's do one thing. I just want to do a small experiment here. We loaded bigger file, right? We loaded bigger file earlier. We loaded bigger file earlier. Okay, I don't know whether the config it can write into it can write into local file system. Let's see. rdd dot persist. I'm doing memory and a disk. Now I will do rdd dot instead of collect, I'll do count. Okay, I'll do count. rdd dot count. Okay, not enough space, cache, some parts. It is showing some partitions. Look at there. Okay, so try to look at the memory storage block manager, uh, memory storage block manager, memory storage block manager. Not enough to cache that 600 score 7 in memory computed this much, and a disk, it is instead of memory, it is written into the disk. Okay, it is done. Okay, it is not failed. Earlier it is failed, now it is not failed. Okay, now go ahead and refresh here. Look at this. Look at this. The bigger file one, don't look at the above one. Above one is other one. Okay, this look at the bigger file one. It is stored total 9 partitions, and it is used memory 24 MB, and rest all it is stored into the disk. Rest all it is stored into the disk. Now also it will clearly showing which one is stored where. Is this clear, guys? Any doubts? Now I did count, right? So now if I do collect, because of the reason why I didn't do the collect earlier, it will display the output like this in the console, like this. It will display the output like this. So it will be clumsy. That was the reason I didn't show. Let me do a collect. Will the collect okay? Yeah, persisted, right? Will the collect work or it will fail? Will collect will work or it will throw out of memory exception?
It will work now, I think.
Not enough space to cache. Not enough space to cache in memory. Computed this much MB, this much MB, this much MB, so forth. Okay, let's see what will happen. It's an action, right? We have only one node, and memory also very less memory. Okay, and we have only one executor. Timeout exception. There will be some time. I think we need to increase the time. That will help. It's not memory exception. At least it's not memory exception. It is a timeout exception. GC over limit exceeds. Okay. This is common error which you get when you do the timeout. Okay. Hmm. Anyway, it came, exception came, right? Let's go to the job. Oh, it is stuck. Sorry, it looks it came out. It aborted the job. Yeah, that's the reason it came out. Finally thrown out of memory. GC overhead limit exceeds. But it should not actually. Mhm. But it should not be. It should not fail like this. Okay. When you do the memory and cache, memory and disk, so the computations will work memory as well as disk. Um, I'll figure it out why it is failed. Okay. Is it because we are running in the local runner mode, or is there anything? Okay, I'll figure it out. Okay. Okay. So the concept of what I was about to show you, persist and cache, how it will work, how they will store into the memory, how to clear them if there's some storage is already there, how to clear that, how to clear that. So that also, how to clear the store already stored data using unpersist. Okay. And how to know which storage level it has using get storage level. There is something called get storage level. It will bring it to the what we are actually making this. Okay, let me do the bigger file instead of memory. I'll read the bigger file. I'll do the persist only disk only. Let's see what will happen. But anyway, the computation. Okay, it missed import disk only. Let's collect. To count. It's a disk only. Okay, everything is stored in disk only. Okay, these are all partitions. Okay, total we have is 9 partitions. They're all partitions. Okay, there's a partition IDs 0 to 9, 0 to 8, and each partition is stored into this. If you see, all are 33, 33, 33, 33, 33. Okay, on the same machine is the same one only. Machine will not change. In case of if you are storing, if you are doing it in a cluster, you will be having a different executors if they are in a different worker nodes. Okay, stages. Only one stage, just to read the data and we did the persist. Locality is a process local. Okay, it was earlier it was any. In other examples it was any, but here it is a process local. Let me do collect. Now at least how it will work. But to collect again, it will bring it to the memory. Again, it will bring it to the memory. For driver. I think still it may throw an exception. Let's see. Hmm. Gone. GC overhead. limit exceeds. It's gone. It's again it's failed. Okay, it will not load. Okay, so this is about the storage levels and persist and what you can say cache. Good. It looks it completed. Or it came out. Yes, someone yesterday someone was asking in case of any failure happen where I can check. Okay, when you click on that, guys, when you click on the details, it will show that. See here it is a console. That's the reason I'm not able to see which data, which source file and all. Normally, if you have written your job like this in a Scala file, okay, something fail or something's stuck. When I click on that, it will clearly shows that. It will clearly shows that information, which file name and which line number also it will show. It will show the file name and line number. But here it is a console. That's the reason it is showing. Okay, you can click. You have to click on the detail. If you want to kill, you can kill also, and also shows that how much duration it has taken. Okay, and one more, let me show that. Look at here. There are total 9 tasks, 3 completed. It's stuck with the fourth. Okay. Mm. Okay, look at here. Which are running, which are also already success. So it was shown 3, right? 3 success, 1, 2, 3. So 3 already completed, and others are running. I think Gautami or someone was asking yesterday, and where can I see that? So you can see that GC 1.4 minutes, GC 1.4 minutes and 2 seconds, and others are still in running. You can clearly know that where it is stuck now, because it is showing running. These pieces are running. Okay, and you can see that total tasks, succeeded tasks. If anything is blocked, how much data is left, how much data is completed, and how much data is left. This is total record number count. I think it's a total record. Okay, and executors, it will list out all the executors and their IP addresses, and which executor also you can see. It will show because the IP address it will show. Okay. It's completely disk only. Environment tells you that what is your default configurations and other stuff. Okay, default configuration and all. What is your scheduler mode and all this. Yeah, I'll show this in another session and explain you. And executors you can see here. You can see here an executor. How many total active tasks? Okay. If you have any SQLs, you can see SQLs here, but so as of now we don't have any SQLs. Okay. So any questions? Okay, that's it for today. So we'll connect in the next session. I don't want to take much time. If you guys have any questions, please ask me. Else we can tomorrow we'll check. Tomorrow we'll see the checkpoint. Another important one. Any questions?
So for both the cache and persist, we need to use unpersist irrespective of the methods
Yes.
for.
Yes.
Okay. So if I want to run the same program multiple times, so
Mhm.
does it read from the memory or it will execute all the steps?
If your job is completed and job is exited, when you do the recomputation, to start from the beginning, it will load again freshly. So that
Then
is the reason. Hmm, Go ahead.
then what is the use of persist here? So usually when we refer to
Within
like
the job, it's a within the job, ma. Okay, we
oh
need to understand within the job, right? See, if
mhm.
you if you're launching a different job, that's a different job ID. So everything is different, right? Again, you're freshly initializing base RDD. Again, you are creating everything. It means that if one time you run the job and store the cache in, if you launch another job, it'll allocate the memory, right? Again, it'll allocate the memory for it.
No, I mean to say if I want to run the same code multiple times, not
That's what I'm trying to say. Every time you run, your persist or cache will execute again and again. The statement
mm-hmm.
will execute again and again.
Mm,
See, this is my one job. Okay, let's take an example. This is one job. I did
yeah,
somewhere here. I did somewhere here cache.
okay.
Say persist. I did.
Mm,
Now I executed this persist will store in the memory for the further actions or further whatever the save as text file or collect or whatever I have written, right?
okay.
So here it will give me the faster results. Let's say I
Mm-hmm.
have my job is completed, my allocation and everything will be released. That's what we discussed in the Spark flow. Yes or no?
Mm-hmm.
Yes or no?
Okay. Yeah.
Once you're completed, once you have written here sc dot stop,
Mm-hmm.
okay, it means all your resources will be freed up,
Okay.
released. Then again you have launched a job.
Mm-hmm.
When you launch again your job, it will start initialize from here, the
Mm.
fresh
Uh-huh.
Spark session. Okay, if it is within the environment, you can create a multiple Spark sessions, but only one Spark context. We'll talk in detail about it. I don't want to make you confused. That's the reason I hold it for now. Let's assume that it is you again. You are starting from here, and again you
Mm-hmm.
are loading the data. Again you are running all these things. Again you are running the persist.
Yeah.
It will be a fresh execution. And when you
Okay.
have a multiple actions here, those will be
Mm-hmm.
faster. It doesn't mean that for job one, it has stored some information. When you call job two, uh, same job again in this, again you launch freshly. It doesn't mean it will not pick the data from there. It's again
Okay.
a fresh job. It's again a fresh
Mm.
DAG, a new DAG, right? Your new
Okay.
context is getting initialized, new driver program getting initialized.
Mm-hmm.
Cache persists and within the application, within the job, if you have a multiple actions and these things, you need to what I can say, uh, uh, avoid the recomputation, then go with the cache persist. It's not
Okay.
across
Okay.
the jobs, it's like within the
Okay.
job.
Okay.
Okay, we'll talk tomorrow about checkpoint, and then with a checkpoint will be completed tomorrow. Then I'll start explaining the cluster allocation, memory, how the internally the memory will be. Okay. Most of the okay zip, yeah, there are a couple of zip and zip with index. I think if it is a possible tomorrow, I'll complete the zip and zip with index, those things in the tomorrow session. Then cluster, memory allocation, those things I'll explain in another session. Mm.
And one more question. So after persist, after this method, we were calling only the actions. So can
Hmm.
we call transformations as well?
You tell me, do we get any advantage if I call actions after transformations of that persist?
Hmm.
I mean,
No,
no, no. What you have understand? I'm not cross questioning you. I'm trying to
no,
make you understand.
no.
So
Here,
I
yeah,
did the
here in
persist.
before examples, you used
Mm,
count
mm,
whenever you're showing us the UI. So you
mm,
are saying I did not call the action, that's why it's not loaded into memory. So
mm.
whenever you say after persist, you whenever you called count or collect, then only we are able to see in the
Correct,
storage level, right? So
correct.
that's why I'm asking. So we only we need to call the action or transformation as well.
No, okay. Let me put in this way. Why, if I didn't call an action, why the data is not loaded into the memory, in the cache memory? Why it was? I didn't call the memory. When I click on the storage, it's nothing. Doesn't have anything. Correct? Why that happened?
Because of lazy evaluation. No.
Obviously, right. Until you call an action, the data will not be loaded. Correct?
Mm-hmm.
So until I call an action, the text RDD will not get loaded the data. The flat map transformation will not be loaded. Okay, the map transformation, the reduce bit, this will not be happen, right?
Uh-huh.
When they will be loaded with the data, when you call an action, even
Okay.
persist cache checkpoint, when you call an action, then only it will allocate the memory for it. Then only the data will store into the memory. Yeah. So your question is valid. After I have did the persist here, after persist, I did some more transformations. Yeah, you can
Mm-hmm.
do that. Till this
Okay.
point, whatever the transformations you have done, those will
Mm-hmm.
be persisted in the memory. After this, whatever the transformations you are doing, those will not be persisted into the memory.
Okay.
Those will not be stored. That information will not be loaded into the memory. Okay, next
Okay.
time when you do the computation, it will not, it avoid the above computations, but it will calculate from here. From after
Okay.
this count towards, you have two more transformations or three more transformations. These three transformations will be recomputed.
Mm-hmm. Okay.
Clear, ma?
Okay. Okay. Yeah.
So that's it for now. If you guys have any questions, please ask me. Else, we can drop off. It's already a few of them. It's already late actually. Few of them already dropped. Any questions? Gauri, Rishabh, Suma, Gautami, Praneeth.
No, Roy.
Okay. Thank you. So thanks for your time. Have a wonderful day. We'll connect in the next session.
Yeah.